Okay, so we're doing number 2 on 4.2, and I simplified the position function, and I did the first derivative using, this is just straight up power rule and then chain rule here. And then I came down and did chain rule again for acceleration, and then I rewrote them without negative exponents. So if you got a question on this, when you watch the video, ask me again in class. All right, so now I want to find out velocity. Velocity tells us some important things. I hope you watched the notes video. It tells us what direction the object's going, when it's right or left or up and down, depending on what the object is. It tells us what direction. And more importantly, it tells us when the object stops. So the first thing we want to do is tell when the object stops. So does anybody know when the object stops? What's velocity got to be for an object to be stopped? 0. So I'm going to take this function right here and set it equal to 0, the velocity function, set it equal to 0 to find out when this thing stops. So I'm going to take this negative and add it over to the other side. So I would get, I'm going to come over here where I got some room. So I would get 1 is going to equal 9 over t plus 1, the quantity squared. Then you got to get this off the bottom. So I'm going to take t plus 1, the quantity squared, and multiply it times 1 to get fractions out of there. Multiply each side by that. Then I would square root each side, so t plus 1 is going to equal a positive or negative 3. And then I would subtract 1, so t is going to equal negative 1 plus 3, which is 2. And t is going to equal negative 1 minus 3, which is negative 4. Now, he's already said this is 0 right here. So over here, negative, you don't have to write this, but you can if you want. Over here, negative 4, I know this object has stopped right here. Well, what's the problem with something moving with respect to time? We don't go back in time. So 99.9% of the time, you ignore the negative time. So the time we're worried about really is the 2. So I'm going to say that 1's here, so I'm going to come out here and say, well, there's 2. There's where the object stopped. Now, I want to know what this object's doing from 0 to 1, or 2, what direction it's going, because if it's moving this whole time, it's going one direction. Then when it stops, it might just turn right back around and go left, or go the other direction, or it might keep going right. I don't know. So I need to find out what direction it's going by the sign of velocity. So if velocity is greater than 0, the object's moving right or going up. So we're going to call it right, though. So what I want to do is come up here in this thing right here, and I'm going to plug in a number between 0 and 2. So I'm going to plug in the number 1 right here. And when I plug in the number 1 right here, I get 1 plus 1 is 2, and you square that, you get 4. So this is 9/4, which I hope we all know. 9/4 would be negative 2 and 1/4. So 1 minus 2 and 1/4 makes this over here negative. So I know the object's moving left from 0 to 2 seconds. And I'm going to plug the number 3 in up here. So if I plug 3 in here, I get 3 plus 1 is 4, that's 16. I hope you know 1 minus 9/16 is a fraction less than 1. That means over here, this object's moving right. Anybody have a question on where any of that came from? Now I want to do acceleration equal to 0. So I'm going to come and take this thing, and I'm going to solve this for set it equal to 0. And I multiply this cube over to the other side, and I get 18 equals 0. Is that true? No. So what that means is the acceleration does not change. In other words, there's no time the acceleration is 0. No time. So that means the acceleration is going to be the same everywhere. So all I got to do is put a number in and see if it's positive or negative. So I'm going to put the number 1 in down here. 1 plus 1 is 1. I cubed 2. I'm sorry, 1 plus 1 is 2. Should have got my calculator out. 2 cubed is 8. 18 divided by 8 is a positive number. So that means this thing is positive the entire time. So acceleration is accelerating to the right. Like if you were jogging to the right and the wind is pushing you in the back, that wind would be the acceleration. If you're driving a car, your gas pedal, also called the accelerator. You push down on it, it goes faster. You hit the brake, you're decelerating, you're going the opposite direction. So that'd be negative. So we want to know the motion. So we're going to talk about speeding up, slowing down, what direction you're going. So from 0 to 2, because that's this 2 up here, this object is moving left because the velocity is negative. And then from 2 to infinity, the object is moving right the rest of the time. Moving right the rest of the time because it's positive all over here no matter what you pick. And now I'm going to talk about speeding up and slowing down. I don't think that's on here, right? Yeah, we're going to talk about speeding up and slowing down on the same thing. So 2 is still in here somewhere, right? You don't necessarily have to put it there, but these are all supposed to be lined up. So the velocity is negative, acceleration is positive. They have different signs. But the velocity, and maybe I'll show you a demonstration when I'm done doing this about what's happening. If these signs are different, then the object is slowing down right here. So the object is slowing here. And again, that's because the acceleration is positive, but the velocity is negative in on that little interval there. And then over here, they're both positive. So the object over here is speeding up. I should have put the word down or slowing down. And now they want to know, where is this object? So you're supposed to plug 0 in. So if I plug 0 in at time 0, got 0 there, I get 9 plus 1 is 10. So at time 0, this object is starting right here. This is time 0. I plug in a 1. If I plug in a 1 here, I get 9 over 2, which is 4.5. 4.5 and 2 is 6.5. So at time equals 1, the object is over here at 6.5. If I do my math wrong in my head, will someone tell me? Check my math, because sometimes my calculator's batteries are low. So in other words, the object's here and it's going this direction. Okay? Then I plug a 2 in. That's where the object's going to stop, right? So 2 plus 1 is 3. Plug a 2 in here. 2 plus 1 is 3. So 9 over 3 is 3. 3 plus 3 is 6. So at time equals 2, the object, oops, I put the wrong number there. We're going to call this 6. And that's time equals 2. The object has moved to here. And then we also know that it stopped right there. It stopped because up here, when t was 2, that's where the object velocity was 0. The object stopped at that 2. Now I'm going to plug in 3. So I'm going to plug 3 in up here, and I get 3 plus 1 is 4. 3 and 1 is 4. 9 divided by 4 is 2 1/4. So 4 and 2 1/4 is 6 1/4. So the object, we'll call this 6.25, I guess. The object has turned around and come back to here at time is 4, or 3, sorry, time is 3. Now, we know you can plug in, let's go ahead and plug in 4. So if I plug in 4 up here, I get 4 and 1's 5. 9 divided by 5 is, I guess I put it way too far off there. But it's still going to be moving this direction, and it's going this direction for the rest of the time because these are both positive and it's speeding up. How many have a question on that? Yes.
So does that mean that like it started going at it started at 10, it like backtracked?
Right. When the bug landed on the windowsill, it landed where the 10 is. And then it started walking to the left. Okay, and it kept walking to the left till it got to where 6 is, and it stopped for just an instant, turned around, and started walking back the other way. That's what And it was slowing down. The object was slowing down all the way until it stopped. And then it turned around and then it started speeding up as it was going to the right, and it kept speeding up as it went. Anybody else got a question? So I said bug because on the AP test a couple of years ago, they had a bug on the windowsill. That's what they thought that this was about. Okay, anybody else got any of these they want to see? Yeah. Number 3. Okay, 45 caliber bullet is fired straight up from the surface of the moon. And this is your position, S, and it reaches a height. So a height's talking about the position. So this is a position function. That right there is S of t. I don't know why I didn't put that, but this is position. Position is height. So now we're talking about going up and going down. So this is my deal. Now, if you remember your formula, this 832 is initial velocity. So that's the speed of the bullet in feet per second. Feet per second, because it says feet after t seconds. On Earth, in the absence of air, the height would be this function. Okay, so in other words, the pull of gravity changes this number in front from the moon, which is less gravity, negative 2.6, and on Earth, we're bigger, there's more gravity, it's negative 16 when you're talking feet. And by the way, when you're talking metrics, that number is, I should say meters, I guess, maybe I should put the word meters. That leading term is negative 4.9 t squared, which is in your notes. All right, so anyway, how long would it take the bullet to hit the ground in either case? So, hit the ground. What does that mean about your height?
0.
It's 0. So you got to take and say your S is 0. Oops, I put the wrong one. That's the moon one. The Earth is negative 16 t squared. And we're going to solve that, and then you plug 0 in for the height on the moon. Somebody got a calculator out, please? So we're going to factor out over here 16t.
52.
And we're going to set both these equal to 0. So what that tells me at time 0, this is my timeline, time 0, and this is time, and out here is 52. They took and they shot that bullet up in the air. And we're saying that the gun was on the ground. They shot it up in the air, and it goes up, and it comes back. Oops, there's 52 right there. That's 52. Okay, so it wants to know how long did it take the bullet to hit the ground on Earth. The bullet hit the ground at t equals 52 seconds, or you could just put 52 seconds, but I like getting into practice of doing at t equals from them because of the stuff we just did in 4.1. Over here you do the same thing. I need a calculator again. We're going to factor out this time at 2.6t. What's 832 divided by 2.6?
320.
So you guys got the idea, right? So this would be it'll hit the moon. On the moon, a bullet hits at t equals 320 seconds. Got the idea, right? Anybody else? Got anything you want me to go over right now? Yeah.
Number 4.
Number 4. Now, see, you guys are just having me do problem after problem because you haven't tried it yet. This is where I got to have you giving me a little effort outside of school. This is where you got to start acting like a college student. College students go to class for an hour for a lecture. You're supposed to spend 2 hours outside of that lecture studying for that class. That's the minimum you're supposed to spend, 2 hours. That's a lot of time. This is a college class. And if you do that in this class, you're going to get an A. If you're not putting in the time, you're not going to get an A And you'll have to take it again next year in college, probably, because most majors need calculus. And then you'll see it'll all be easy because you've already seen it all. Phineas and Ferb. Are you guys old enough to know that cartoon?
Yes.
I used to like that. Are standing on the top deck of the Eiffel Tower, which is 906 feet high. Anybody know what that stands for? And our position function?
Height.
Which height?
The Y height.
Kind of.
Vertical.
It is vertical, yes. Phineas drops a penny while Ferb throws his penny and it hits the ground in 8 seconds. How long will it take Phineas's penny to hit the ground, and what is the initial velocity of Ferb's penny? Okay, so this is kind of a tough one because we got to find a couple of things out. So I'm going to tell you again, this is on the first notes. S of t is going, now we're talking feet and seconds, right? So this is going to be the negative 16t squared plus b sub naught t plus s sub naught. B sub naught, whenever you write a little zero down here, if you haven't had science yet, physics or any of that stuff, they use the same symbols. This is initial velocity, and this is initial height. So can anyone tell me what the 906 is now?
Initial height.
That's the initial height. Now, Phineas is going to do what to the penny? Drop it. Did he throw it? No. So what would the initial velocity be for Phineas? If he just stuck his hand out and opened his hand and dropped it? Zero. So in other words, and maybe I should put above this Phineas so we know whose this one is. This is Phineas right here. Phineas is going to be negative 16t squared plus 906. You don't put the middle in there because the velocity is 0, and 0 times anything is 0. So there's that. Now we want to know how long it took the penny for Phineas to hit the ground, because we got to find out actually we don't. Yeah, let's see. All right, let's just come over here and write the other equation. So we got Ferb over here. Ferb is over here, and his position is like this, but he is going to take the penny and he's going to throw it. So he's going to throw his penny and it hits the ground in 8 seconds. Now, is he throwing his penny up or down?
Down.
Do you know?
No.
We don't know. So we are going to have to solve this. We want to find out how long did it take Phineas's penny to hit the ground when he just dropped it. Because if 8 seconds is less, that means he's throwing it down. If 8 seconds is more, that means he's throwing it up. So let's put a 0 in here. So this is almost like the exact same problem we just did. We're going to factor out a negative 16t. That's going to be t minus, what's 906 divided by 16?
How can you take a t out of that?
What?
How do you take a t out of
Oh,
that?
you're right. We don't. You are right. I'm wrong. So we said negative 16t squared plus 906. We're going to add 16t squared over. Then we're going to divide 906 by 16. Can anyone tell me what that is? 906 divided by 16?
56.625.
And then we're going to square root that number. So t is going to equal positive negative what?
7.525.
7.525. So, now we're not going back in time. So in other words, when he just dropped it, it took us 7.525 seconds to hit the ground. So Phineas is throwing the penny where? Up. So our velocity here is going to be a positive velocity. So we're going to come over here and we're going to put 0 in here. And we have to solve for this velocity. How long will it take Phineas's penny to hit the ground? And what is the initial velocity of Ferb's penny? All right. So we are going to do what here? What do we know that we can plug in to find velocity? 8 seconds. We know that it took 8 seconds 8 seconds to hit the ground. So we're going to come in here and we're going to plug in 8, 8. And now we're going to solve this. So will someone tell me what 8 squared times negative 16 is?
Negative 1,024.
So we're going to take negative 1,024 plus 906. What's that equal? Combine like terms.
Negative 118.
One what?
118.
We're going to add the 118 over. We're doing algebra 1 now. We're going to divide by 8. Oops. Divide by 8. What's 118 divided by 8?
2.25.
It's going to be, is that exactly it?
Nope, I have that.
I got to have at least three decimals. Anybody got it?
14.75.
14.75?
Yes,
Does it stop at 0.75?
yes.
So that means that Ferb threw the coin up in the air at an initial velocity. Oops, I put seconds, that's wrong. At an initial velocity of, now what would velocity be in terms of? Feet per second. So he threw it up at an initial velocity in feet per second. So I'm going to stop there for now. Not to blind somebody. And I'm going to have you guys work on this stuff, and I'm going to give you some visual demonstration here about acceleration and velocity and why they slow down or speed up. So I'm going to go ahead and get this thing set up. Problems did we do?
2, 3, and 4.